So guys, just a reminder that your section 6.1 quiz that was on quizzes, remember I posted it yesterday, but I told you guys, because of those of you who were taking the ASVAB test yesterday, I didn't want to overwhelm you if you were tired. So it's not closing until tonight. A lot of you already did it, which is great. But if you didn't, don't forget that quiz will close at 11:45 tonight. So please try and get that done. It's 10 questions, multiple choice on quizzes, okay? The link is on your Google Classroom. All right, here we go. We are going to start section 6.2. Section 6.2 is still working with functions. In the first section, we were looking to do operations with functions, how to add them, how to subtract them, how to multiply or divide to make a new function, right? Well, in this section, we want to learn how to make an inverse function. How do I make a function that will undo another function, okay? So that's what an inverse function is. An inverse function is going to be a function that undoes another function. Okay? And then I put a little note here that says, by definition, the inverse is a function, so it must follow function behavior. Thank you, Marquita, I appreciate that. What I mean by that is, remember, to be a function, you have to show that when one number goes in, only one number could come out. You don't want to have a number go in and two different outputs come out. That's not how a function behaves. One input and then one output, okay? So you want to make sure that an inverse does that as well. So certain functions, when you try to undo them, they produce more than one output. And in that case, we would say the inverse doesn't exist because that inverse doesn't behave like a function, okay? That's more something that you would get into in pre-calculus. Right now, all we have to worry about is just finding an inverse, finding a function to undo another one, okay? All right, so let me give you an example about what I'm talking about. So guys, for example, this is what we want inverse functions to do. If I plug a 9 into a function and I get a 14 out, right? That creates the ordered pair 9, 14. 9 went in as the input, X, and 14 came out as the output, Y. And we can form ordered pairs. Okay, so what's going to happen then with an inverse, when I plug 14, that output, into the inverse function, everything that happened to make that 14 come out is going to be undone, and you're going to get 9 out of the inverse. All right, so it's going to undo everything that happened to that output to make us go back to the original input. All right, so that means 14 went into the inverse as X, and then 9 came out as the output as Y. So that means the point 914 would be on the first function's graph, but then the point 14.9 would be on the inverse function's graph. Okay? Same thing. If I plug -8 into a function and something happens to it, and I get -3 out, that's going to create the ordered pair -8, -3. -8 went in as X, and -3 came out as Y. So an inverse function is going to take that output, that -3, plug it into the inverse. Everything's going to get undone to that -3, and the inverse is going to spit -8 out. It's going to bring you all the way back to who you originally started with. So that means -3 goes into the inverse as X, and then -8 comes out of the inverse as Y. So therefore, when you look at it from an ordered pair standpoint, the inverse function is going to reverse all the ordered pairs. All of the original X's become the Y's on the inverse. All of the original Y's become the X's of the inverse. It just switches the order of the ordered pair to do that undoing, if you will, okay? All right, so I put some important notes in this box down here. Right? So that's how we can look at it with numbers, but from a general standpoint as x and y, x is always going to be the one that goes into the original function, and y is going to be who comes out, right? That means the point xy is on the original function's graph, if you were to create a graph from all of these points. And then y is who goes into the inverse function. All of those operations get undone, and x is who comes out of the inverse. So then the point yx is on the inverse function's graph. All right, so therefore x and y, they trade roles, guys. And I put a little spoiler. Not only are x and y going to trade places in the ordered pairs, they trade places everywhere. If you had an equation for the original function, then x and y would trade places in the original equation, and that's how we could create the inverses equation, by making x and y trade roles. Okay? The original function's outputs become the original function's inputs. The original function's inputs become the inverse function's outputs. All the x's and y trade roles, right? And also, when we were working with domain and ranges, domains were our x values and range were our y values. It means that would trade too. The domain of the original function is the range of the inverse. The range of the original function is the domain of the inverse. All of your x and y roles trade roles. Okay, so let's practice a few examples. Okay, so for example 1, they want you to find the inverse of the given set of ordered pairs. Guys, this is as easy as the questions are going to get. If they want you to find the inverse of a set of ordered pairs, all you have to do is take all those ordered pairs and switch x and y. So if this is a point for the original function, then the inverse would have the point -3, 5, right? And remember, ordered pairs tell a story. This ordered pair says that 5 went into a function as x, something mathematical happened to it, and a -3 came out as y. All these ordered pairs tell a story. Now this ordered pair says, well, -3 went into the inverse, and the inverse spit out 5. All right, if this is an ordered pair on the original, then just switch it. Now we know 6, 0 is on the inverse function's graph. All right, so just switch all your ordered pairs. 8, -4, 7, 1, and then -2, -9. And then that would be the inverse, right? The ordered pairs where x and y have been switched. Okay, nice and easy, right? All right, well, that's how you can find an inverse when you're given a list of ordered pairs. What if they give you an actual function and they want you to find the inverse function? What is the mathematical expression that is going to undo what the original function did? If you want to write the equation for an inverse function, how do we do that? All right, let's say you were given the function f of x equals x plus 3. Find its inverse function in slope-intercept form. Guys, it just means they want it in y equals mx plus b form, okay? All right, well, guys, think about this. Look at this function right now. You're going to plug a number in and add 3 to it, okay? Can anybody think, what would the inverse function possibly have to do to undo this function adding 3? Can anybody think what operation in math would undo adding 3 to something? Does anybody know? If this function is going to add 3 to something, what operation would undo that and make it act like it never happened? Subtract 3, yes. So think about it. That's what we want the inverse to do. We want the inverse to take the input and subtract 3. That's what we need it to do. So let's see if we can get that function. All right, so guys, if you want to find an inverse, take the original function, which is f of x equals x plus 3. Well, guys, remember, f of x is y, right? So replace f of x with y. So rewrite this as y equals x plus 3. All right, so now we're looking at it with x and y instead of f of x and x. All right, well, if we're going to create an inverse, then we need x and y to trade rules. So you literally switch them. Switch the x and y in the equation. So now let this say x equals y plus 3. Trade them. Okay, guys, believe it or not, This right here is the inverse function. That is the equation that will undo what the original function did. However, it's not in the correct form. We always like it so that x is the input, the one who lives inside the function, and y is the one who comes out of the function. So we always like our function to be y equals something in terms of x, right? So now you have to take this equation that you switched x and y in, and you have to resolve the equation for y. You got to get y by itself again. So guys, how are you going to get y by itself? It's fairly simple. How do you get 3 to go away? Just subtract it. So we're going to minus 3 to the other side. All right, and then we're going to have x subtract 3. They're not like terms, so keep them separate. X subtract 3 equals, what's left on this side? Y. So we did it. Let's just rewrite it with y on the left side. So let's rewrite it as y equals x minus 3. So guys, look at this equation. This equation, you're going to plug a number in. Now you're going to subtract 3 from it. That's going to undo this function, adding 3 to something. Okay, well, when we're dealing with functions, we always like to be in terms of like f of x, right? So the way they write the form of the inverse, the notation that they use, is it looks like you're raising f to an exponent of -1, but we read it as f inverse of x. But that's the notation they want you to use. So now you're going to take y out and replace it with f inverse of x. So we don't want y, we want f inverse of x to equal x minus 3. And that's the inverse function. That's the function that will undo what the original function did. So guys, watch this. Let's say you found f of 4. If you plugged 4 in, what's 4 plus 3? 7. So 4 went into the original function, and 7 came out, right? Well, now, if this is his true inverse, I should be able to plug 7 in there and get who out? 4. If you plug 7 into the inverse, what's 7 minus 3? 4. It gets the original input out. It undoes everything, okay? So that definitely is the inverse to that function. Does that feel okay? All right, so really, to find the inverse function itself, it's just switching x and y and then resolving it for y. So as long as the original function isn't too complicated, it shouldn't be that hard to switch x and y and then resolve it. All right, let's try another one. Let's get some more practice. And remember, they're asking that your answers be in y equals mx plus b. Guys, y equals mx plus b. This is mx plus b form. M is 1, b is -3. This is perfect. All right. All right, so now I just gave you a couple different functions. We're going to try and find their inverses, all right? Let's find functions that will undo what these functions are doing. Okay. Well, first of all, here's function f of x. We have to find a function that will undo what he's doing. So first things first, replace f of x with y. Okay? Now, to start finding the inverse, remember, x and y literally have to trade roles. So switch them. Now we're going to rewrite this as x equals 2/3 y minus 4. Okay, you have two options. If you guys remember, when we're working with fractions, if we're working with an equation with a fraction, you can multiply all of your tops by a magic number that will make the fractions go away. Otherwise, we can just deal with the fraction once we get to it. All right, so guys, our job is right now, how do I get y by itself? Well, we always move what's not attached away first, right? So let's add 4. Okay, then we're going to get x plus 4 equals 2/3 y. Okay, I'm not sure how you guys are going to be most comfortable handling this. The quickest way to get y by itself, guys, is what you would say is, well, I'm just going to divide 2/3. That's fine. But now you're dividing everything on this side by 2/3, and that can get a little bit messy, especially when they want you to leave it in mx plus b form in two separate pieces. All right, one thing you could do is you could take it in steps. Right now, in order to get rid of the 3, the dividing by 3 part, I could times this by 3, and it would cancel, and then I would just be left with 2 times y. But guys, if I times this side of the problem by 3, I have to times this side of the problem by 3. So I have to times this by 3 and the 4 by 3 as well. So now I have 3 times x plus 3 times 4 is 12 equals 2 times y. And now what's the only thing you have left to do to get y completely by itself? Divide by 2. And since they want you to be in mx plus b form, I want to divide everything by its own 2. So let's divide this by 2, divide this by 2, and divide that by 2. Divide everything by its own 2. All right, they cancel. That's why we divided by 2. All right, does 3 divide by 2? No, and it doesn't reduce. So guys, we're going to leave that as 3 over 2 times x. And then plus, what's 12 divided by 2? 6 equals y. And we did it. We have y by itself. We have found an equation that will undo whatever this one did. All right, so here we go. So now we're going to get, y equals 3/2 x plus 6. But remember, they like you to put f inverse of x. So now take the y back out and put f inverse of x in. Now guys, I should have checked this and I meant to. If I have time at the end, I will. On Delta Math, they may have this written in front of the answer box for you. So then all you have to type into the answer box is this part. You might not have to type that because I think it's written in front of your answer box. But just double check. Okay? All right, let's look at this one. What if we had to find the inverse function to that function, a function that will undo what this function is doing? All right, everybody, let's go. We're going to first put our y in, so let's replace f of x with y, and it equals 3x plus 5. Okay, well, to begin the process, we have to switch x and y, so switch them. All right, so basically there it is. That is the inverse function, but it's not in the form that we want. We want y by itself. So how are we going to get y by itself? Well, we always move what's not attached first, right? So it's minus the 5. That's going to leave me with x minus 5 equals 3y. What's the only thing you have to do to get y by itself right now is divide everything by its own 3. Okay, well guys, remember, it's not really x that we're dividing by 3, it's the number in front of x. And what number do we have to assume is in front of this x? 1. So it's 1/3 times x is really how we would write that. And then minus 5 divided by 3, well, 5 doesn't divide by 3, and it doesn't reduce. So we're going to leave it as minus 5/3. And then it equals y is finally alone. And there's our inverse function. I just like to write it with y on the left. And again, this is mx plus b form. We're in perfect form. Right? But now we just take y out and we replace it with f inverse of x. So we are just switching x and y and resolving for y. And that's how you can create an equation that will undo what the other one is doing. All right, I'm going to let you guys do C. You guys do C. I'm going to give you a head start, see what you guys get. Let me double check the attendance while you do that, and then we'll be good to go. just going to do it up here. Right? First I replace f of x with y. Now I'm going to switch my x and y. I don't switch anything else. Don't switch signs. Don't do anything. You just switch x and y. This is now x, and this is now negative y minus 6. And now we just begin the resolving process. Get y by itself again. So now I have to add 6. That leaves me with negative y, which is close. We want y by itself. This is negative y. So all you have to do then is divide everything by negative 1. All right, and then negative x minus 6 equals y. So then y equals, and then I switch that with f inverse of x. Okay, how do you guys feel? Do you feel okay? Are you guys all right here? Okay, Jenna, you all right? All right, at home, are you guys okay? Awesome. All right, so guys, that's how we find an inverse function. We're probably going to work on this section again tomorrow, and then Monday will probably be a review, and then Tuesday will be a quiz. It's a quick section, and I'm just trying to quiz you each section at a time as we go through, instead of giving you, like, quizzes on multiple things or even tests. We're just kind of testing each thing as we move through it, and then we're on to the next topic. All right, so tomorrow we'll do it again. And then, like I said, review Monday, quiz Tuesday, I think is what I'm looking at so far. If anything changes, I'll obviously let you know. All right, if I say your name, you're good to go. If you have any questions, please let me know.